I will be recording this lecture, so if you don't want to speak during the lecture, send me a chat, but I just want to make sure that you know that the recording is on. Today, we are going to learn about parallel force systems in equilibrium. Parallel force systems in equilibrium. Last time we talked about concurrent. This time we're going to talk about parallel. So if you remember, a parallel force system, all the forces are parallel, whatever they happen to be. We're going to usually have rollers and pins supporting. So these are going to give us supports that are in the same direction as our two things. So like if this is point P and point Q, that's what I use a lot. How do we solve these problems? Step one. Find the sum of the moments about the leftmost point and set it equal to 0. I always use the leftmost point just so I'm always using my moments. The rotation looks the same all the time. So I always know clockwise and counterclockwise real easy. So that's why I always choose the leftmost point whenever possible. Now sometimes it's not possible, but most of the time I'll use the leftmost point. Now, the leftmost point, this has to be, what I mean by leftmost point, this is a point of support, where the support occurs, because that's what it's going to rotate about. So if this point weren't out here, if the point were in here, if we had a circle in here, and this was point P, then that would be your leftmost point. In here, oh, didn't want to do that. This would be your leftmost point. So whatever is the point of rotation, or where the support is, that's the first thing. So when you do this, this is going to yield, or you're going to be finding right support, which in this case is Q. That's step one. And then step two, we are going to find left support, which is P in this case, by taking the sum of the forces in the Y and setting them equal to 0. So that's it. Those are the two steps for parallel force systems in equilibrium. It's probably the easiest thing we're going to do the whole year. So we'll just try some problems for as long as till we get tired of them. Let's just start here. I will draw an object, right? We got a pin here. I'll call this guy P, this guy Q. Put some forces in, some distances. So we'll say A is 2 tons, B is 4 tons, C is 2 tons. And this is 2 feet, 2 feet, 2 feet, 2 feet. And the problem would say something like, find the reactions at P and Q, the weight of the beam is negligible, which means compared to 2 tons, the weight of that beam isn't very much. So the reactions at P and Q, those are what we draw in here, right? We got that, and then we got one over here, a roller and a knifed edge. Now you know a knifed edge also has an X support, right? P, Q. But there's nothing for it to react. There's no left to right movement in this system. So the support at P that's in the X direction gets eliminated. We're not worried about that. We won't worry about that until non-concurrent force systems. But it's there if it needs to be, because that's a knifed edge. So what we want to do here is our first step is to sum the moments about P and set it equal to 0. So that gives us, we're going to start here at P and we're going to move left to right. We're going to go this way and we'll just take 2 times 2, that's negative, right? Clockwise rotation. Minus 4 times 4, minus 2 times 6, plus Q times 8 equals 0. So if we add those up, what do we got? 4 plus 16 is 20, plus 12 is 32. Q equals 4 tons. Did I do my math right? Did it in my head. I'll check it just because sometimes I'm wrong, but 32 divided by 8, I know that's 4. And then we sum the forces into Y and set them equal to 0. Again, we'll just go left to right. P minus 2 minus 4 minus 2 plus 4 equals 0. P equals 4 tons. Yeah. That's it. That's how you do parallel force systems in equilibrium. Anybody have any questions on that? All right, let's try one where they're not at the far ends. They're in the middle somewhere. Put a roller in here. Now these are a little harder. I have to make sure that I have it so the roller is not as an upward force. So let's just make this. A is 100 newtons. B is 70 newtons. C is 250 newtons. And we'll just make our distances. Looks pretty much like they're all the same. 4 meters, 4 meters, 4 meters. So again, we'll put our supports in. So I got a support here. I'll call this guy P. This one Q, P. Over here, I got a support Q. And I just go through the, remember going left to right again. Sum of the moments about P equals 0. So I got 100 times 4, that's positive. 70 does not create a moment, it's right through the point. Minus 250 times 4 plus Q times 8 equals 0. So 400 minus 1,000 plus 8Q equals 0. 8Q equals 600. Q equals, this is a repeating decimal. Oh no, it's not. 7.75. 75 newtons. Then we do the same for the sum of the forces in the Y. We set those equal to 0. Up. P minus 100 minus 70 minus 250 equals 0. Oops, I forgot that Q. Plus 75 equals 0. Right? Q is equal to 75. P equals 350, 420, 345, 345 newtons. Anybody have any questions on that one? All right, let's try another one. All right, this one might be a little tricky. We have P and Q. They're both pins this time. And I'm going to say A is 10 kips. B is 14 kips. C is 12 kips. And D is 7 kips. And we'll give out some distances here. 1 foot, 1 foot, 6 foot, 2 foot, 1 foot. And what we're trying to find is the supports at P and Q. Now, they're pins, so they might be downward. So we have to do our math and make sure we're doing it correctly. Always guess positive. And then if it comes out the opposite, you know that you did it, it goes the other way. So always draw your forces when they're unknown as positive forces. Then when you're doing the problem, if they come out opposite, you know you drew them the wrong way. So we're going to do like we just did. Sum of the moments at P equals 0. We'll start at A and move to D. So A, that's rotating it clockwise. That's -10 times 1. At B, that's rotating it clockwise as well. So that's another subtraction. Right, they're both spinning it clockwise. -14 times 1. C is 7 away from P. So that's -12 times 7. And D is the only one rotating counterclockwise. Oh my, where'd that go? Where'd it go? There it is. And then D is 1, 3, 9, 10 away. Wait, the 12 is 7. D, or I forgot Q. Q, we're going to assume is, we didn't draw them in here. Q, we're going to assume is an upward force. Same with P. So P and Q. So Q is plus Q times 9. And then D is 7 times 10. We'll set those equal to 0. So we got -10, -14, -84, plus 9Q, plus 70 equals 0. So that's 24, 108, 70, 38. 9Q equals 38. Q equals 4.22 or 44.22 kips. And then to find P, we'll do the sum of the forces into Y, set that equal to 0. So we got 10. 10 plus P minus 14 minus 12 plus 4.22 plus 7 equals 0. 10 minus 4 minus 16 minus 9. So that's 4.78 for P. 4.78 kips. I think that math's right. I did it in my head, so I'm trusting my math. So that's how we do the moments. I mean, not the moments, the non-concurrent force systems in equilibrium. Anybody have any questions before we try a couple at our seats? All right, I'm gonna make some up. We'll probably do about 3 of these at our seats, and then I assume if you can do 3 of these, you can do them all. They're pretty easy. Start out light. All right, when you're done with this, give me the thumbs up. How are we doing? Are we done? Am I seeing thumbs up? All right, good, good. A lot of thumbs up. So let's take a look, see how this one's done. We're going to have a force out here at Q and a force out here at P. Some of the moments about P equals 0. A does not create a moment, so we can go to W. 250 times 5, and that's a negative moment. And then we have 190 times 9 plus Q times 10 equals 0. I may have to get my calculator out for this. $296. And then sum of the forces in the Y equals 0. We have negative 150, P minus 150, minus 250, minus 190, plus 296 equals 0. So that's 400. Negative 294, is that right? 590, 390, 300, 294. Good? Thumbs up? Somebody give me a thumbs up so I know my math is right. Glenn, quick on the draw. Anybody have any questions there? Let's try another one. I know it's boring, sorry. I know you like the more challenging, exciting problems. Don't worry, they're right around the corner. Uh, 75, 750 newtons, 500 newtons, 600 newtons. Three meters, 2 meters, 2 meters, 3 meters. Give this one a try. All right, let's solve this problem out. We got P, and we got Q. We'll take the sum of the moments about P, set them equal to 0. We got 750 times 3, and that's counterclockwise, so that will be positive. And then we got 500 times 2 going clockwise, so that's negative. And the 600 is negative too. 600 times 7. And we can't forget Q times 4. Set that equal to 0. I'm going to need this crazy calculator again. I got 2950, and I'll divide that by 4. Q is 737.5. I'm going to do forces up here just because for some reason I stuck everything right in the middle. So we have negative 750 plus P minus 500 plus Q minus 600. Oh, I'll put Q in there. Plus 737.5 minus 600 equals 0. P equals 1112.5. How'd we do on that one, team? Class. Nice. See, I told you these were easy. All right. Does anybody have any questions? You are free to go. Work on your homework for tonight. Make sure you do those homework problems in the book too before the exam on concurrent force systems.